Yes. Hello students. All of you welcome to Gradeup, India's largest online platform. All of you very good evening sir. Welcome to the session students. Today topic is most important models of questions based on the digital voltmeter students. Yes students, all of you good evening. Welcome to the session students. Today topic. Yes students. Yes, good evening students, all of you. Maithili, good evening. Lokesh, good evening. Welcome to the session students. Before starting the today concept, first let me introduce myself. Students, my name is Surendra Babu. For 10 years, I am educating the students for GATE ESE and PSUs in electrical and electronics engineering students. Yes, students, these are the subjects I am teaching: network theory, power electronics, electrical missions, power systems, electrical and electronic measurements, transducers and mechanical instrumentation. Yes, students, this is about me. This is a Gradeup Super students. Subscribe for Gradeup Super, get the so many benefits. This Vision 2022 English batch. This is a course for ESC, GATE and PSUs. This also Vision 2022, that is Hindi. Vision 2023, both Hindi and English is batches are there students. Students, to get unlimited access to your preferred courses, subscribe to Gradeup Super. For more information, call to this number students. If you want more benefits, who are preparing for, who are the aspirants for GATE, ESE and PSU students, subscribe for Gradeup Super. Yes, students, these are our star faculty. Please go through the lectures of all our star faculty in electrical and electronics engineering students. Yes, students, this GATE 2021 results in our Gradeup. In every branch, we got the top 10 results, students. Please concentrate. Siri Vanilla, good evening. All of you, welcome to the session, students. Welcome to the session. Yes, students. Today I am solving the questions on digital voltmeters. Who are preparing for ESE point of view and even for GATE point of view also. These models are very important, students. Yes, students. The first question is displaying on the screen. Can anybody answer this question, students? Quick. Yes, friends, all of you join the session and inform to all your friends and like and share the session, students. Yes, friends, the first question is displaying on the screen. Please read the question, answer the question, students. A digital voltmeter has 4-digit display. The 1 volt range can read up to. That is, it is a 4-digit digital voltmeter, students. It is a 4-digit digital voltmeter. Then it can read up to what voltage it can read in 1 voltage range, friends. It's a 1 volt range. Yes, students, point to remember here. It's a 4-digit DVM. It's a 4-digit DVM. That is 4-digit digital voltmeter. 4-digit digital voltmeter DVM. Then it can read up to in 1 volt range, friends. In 1 volt range, it cannot measure the 1 volt. It cannot measure the 1 volt. That is one of the main drawback of digital instruments, digital meters. It can't read full scale. We are measuring 1 volt means it cannot measure 1 volt exactly. Then it is a 4-digit DVM. It measures 0.9999 because the display is in 4 digits, friends. The display is in 4 digits. That's why it measures the 0.999 it can measure. Actually, the display is like this. 0.999 it can display because it's a 4-digit DVM. Very good, sir. Very good. Yes. Yes, Sahan, it is correct. Very good. Shiny. Yes, sir. It is electrical, sir. Mainly it is electrical, then electronics. It's electrical, sir. I am the electrical faculty and it is electrical subject. But in ESE, this is for ECE also. For instrumentation, for gate point of view also it is. Main it is electrical subject. Govindam, option A. Sirivennala, option C. Sahan, you given option A. I think it is wrong. You please check this one. Then which is the correct answer, students? Option C is correct. Sirivennala, it is correct. Okay, Gurjit. Yes, friends, please concentrate. Then it measures how much voltage, sir? 0.999 volts it measures. In 1 volt range, it cannot measure the 1 volt. Okay, that is the one of the main drawback of digital voltmeters. It's not option D, sir. It is the option C only. It is not a 4.5 digital voltmeter. It is a 4-digit digital voltmeter. It's a 4-digit digital voltmeter means maximum it can measure this voltage. Yes, friends, please concentrate. The next question is displaying on the screen. Can anybody answer this? Quick, students. Which one of the following is not true of digital instrument? Just now I told that statement. Which one of the following is not true of digital instruments? Yes, friends. Loading of the circuit under measurement is less. Yes, it is correct statement. Because digital instrument offers high input resistance or high input impedance, the loading effect is less. Yeah, that is correct statement. But it is asked not true. It is not true for digital instrument. Next, accuracy is better. Yes, digital instruments are having very high accuracy. As compared to analog instrument, digital instruments are having high accuracy. It's free from observational errors. Yes, there is no any parallax error in the case of digital instrument. But in the case of analog instrument, there is a parallax error. But there is no any observational errors in the case of digital instrument. You want to find wrong statements. Can present the regarding in overall context of range. Just now I told. In measurement of 1 volts, it cannot measure 1 volt. It measuring 0.999 volts it is measuring. But here what it is given can represent the regarding in overall context of range. Total range it is measuring. That is wrong, sir. That's why this option is correct. Option D is correct. Govindan, very good, sir. Option D is correct. Srikanth, very good evening. Welcome to session. Sirivennala, it is correct, sir. Kumari, yes, very good. It is correct. Sahan, it is correct, sir. Gurjit, very good. Option D is correct. Just now I given that statement. Yes, friends, please concentrate. The one more question is displaying on the screen. Can anybody answer this question? What is the range for a 3.5 digital voltmeters? What is the range for a 3.5 digital voltmeter? Yes, friends, this mainly in the case of digital voltmeters. Mainly in the case of digital voltmeters, this half range, half digit, 3 by 4 digit, 5 by 6 digits. These are used to extend the range. These are used to extend the range. How you can extend the range? All this you know in the concept. Here I'm not explaining the total concept, sir. I'm solving the questions. What is the purpose of using this half digit, 3 by 4 digit, 5 by 6 digit in the case of digital voltmeter to extend the range, sir? Actually, students, what about the 3-digit digital voltmeter is there? If it is a 3-digit digital voltmeter, students, if it is a 3-digit digital voltmeter, it can measure, this is 0 to 999, sir. Maximum 999 it can measure. I'm talking about maximum. 999. The name itself it indicates 3 digits. Maximum it measures 3 digits only. 3, that is 3 double lines. That is 3 nines it can measure. Understand? But it is given 3.5 digit DVM, students. If it is a 3.5 digit DVM, it can measure 0 to, there is no change in the resolution. Because of half digit, 3 by 4 digit, 5 by 6 digits, friends. Minimum value cannot affect. There is no change in minimum value. Because of all these digits, range is extended. Scale is extended. The maximum value measured is extended. But there is no effect in the resolution. There is no effect in the sensitivity. There is no effect in the minimum count. Because of this half digit 3 by 4. Then because of 3 and half digit, because of half digit, this is rollover by 1, sir. It is roll, 1 indicates 3 and half. This 1 indicates rollover by 1. 1999. That is 0 to 1999 it can measure. 0 to 1999. Which option is correct, students? Option A is correct. Yes, friends, please concentrate. It is a 3 and half DVM. It is a 3 and half DVM. It is not 0 to 149. It is a 3 nines only because previous one is 4, sir, 4 digit. But it is a 3 digit. 3 digit means 0 to 999. 3 and half means, students, please concentrate. In this 3 and half, 1 indicate the rollover, sir. 1 indicate the rollover. That is rollover. That means it is rollover on the full scale value. 2 indicate the multiplication factor. 2 indicates which one, sir? Multiplication factor. Multiplication factor. Multiplication factor means how many number of count it is asked. How many number of counts, students? How many number of counts here? 2 into 10 cube counts. 2 into 10 cube. That is how many counts? 2000 counts. In the case of 3 and half, how many number of counts? 2000 counts. 0 to 1999. 0 to 1999 is how many counts? 2000 counts. If it is a 3 digit, sir, it is a 3 digit. How many number of count it is asked? How many number of counts, students? In a 3 digit DVM, how many number of counts, sir? Into, that is 10 cube only. That is 1000 cube, 1000 only. You don't multiply into 2. But it is 3 and half means the denominator indicates multiplication, sir. This numerator indicates rollover. Like that you remember. Yes, friends. Yes, very good, sir. Option A is correct. Saujanya, very good evening, sir. Very good evening. Welcome to the session. Yes, option A. Sirivanala, option A is correct. Very good, students. The next question is displaying on the screen. Can anybody answer this one? Quick, students, quick. Very important models of questions who are preparing for different competitive exams. Yes, friends. Yeah. Majority of digital voltmeter are built with a dual slope ADC because most of in the digital voltmeter, what type of ADC we are using, sir? Dual slope ADC we are using. Dual slope ADC we are using. Saujanya, I'm not understand what that. Most of the in dual slope ADC, most of the digital voltmeter, what type of ADC we can use, sir? Dual. There is mainly 4 types of ADCs are there, students. Flash type ADC, successive approximation ADC, RAM type ADC, dual slope ADC. Mainly these are the main ADCs we are preferring in the case of digital voltmeters. Once again I am repeating, flash type ADC. This flash type ADC is also called parallel ADC. The next one is successive approximation ADC. Third one is RAM type ADC. The fourth one is dual slope ADC. These are the 4 ADCs mainly we are using in digital meters. But most preferable ADC is which one, sir? Dual slope ADC. That is a dual slope integrating type ADC. Dual slope integrating type ADC. Why you are using this ADC, sir? Yes, sir. Yes. Dual slope ADCs are less complex than other type of ADCs. It is wrong, sir. It is a more complex. As compared to other type of ADCs, it is complex. Dual slope ADCs are faster than other type of ADCs. Absolutely wrong, sir. Absolutely wrong this one, sir. Absolutely wrong. Dual slope ADCs are faster than other type of ADCs. It is among all the ADCs, it is the slowest ADC, sir. Slowest ADC. Very low speed. Highest speed is flash type. The name itself it is flash. Flash. Is a flash type ADC is the highest speed, sir. Highest speed is flash type, sir. Highest speed is flash type. That point to remember. Lowest speed is dual slope. Next, dual slope ADCs can be designed to insensitive to noise and interference. Yes, it is the exact statement. Dual slope integrating, the name it is a dual slope integrating type ADC. In dual slope ADC, there is a 2 important parts are there. Comparator is there, integrator is also there. It's the integrating type ADC. Integrating type means integration is nothing but a summation or average. It measures the average value. On any input signal, let I am giving the input is DC, sir. on any input signal, if any noise signal is imposed, if any noise signal, sinusoidal noise signal is imposed, sinusoidal noise signal is imposed, because of average, this average value becomes 0, then noise effect is eliminated. Noise effect is eliminated. That's why these are designed insensitive to noise and interference. It is not affected by the noise. That means high noise rejection ratio. These dual slope ADCs are having high noise rejection ratio. High noise rejection ratio, sir. This dual slope. This is one of the main advantage of dual slope ADC, sir. Yes, friends, please concentrate. Why these are more preferable? This is the reason. High noise rejection ratio. High noise rejection. These ADs are having high noise rejection. This is not affected by the noise. Once it is having high noise rejection ratio, this is highest stability. Dual slope ADCs are having highest stability because it is not affected by the noise. That's why it is a more stable ADC. It is a more stable, sir. Because it is not affected by the noise, it is a more stable. Dual slope ADCs provide BCD outputs, but that is wrong. Dual slope ADCs not provide the BCD outputs, sir. Dual slope ADCs we are using in terms of pulses. The output is in terms of pulses. But successive approximation is BCD output. Successive approximation ADC is the BCD output. That's why it is also wrong. Ramp type and dual slope, sir. The output is in the form of pulses. The output is in the form of pulses. But successive approximation, the output is in the form of BCD. The output is in the form of BCD. Yes, clear, friends? Yeah, whatever the point, not only answer you concentrate. Whatever the points I am giving, that points also you concentrate, sir. That points are more useful to solve the different models of questions in any competitive exam. Yes, friends, all of you welcome to the session, sir. Yes, Sirivennala, yes, option C. Saujanya, option C is correct, sir. Very good, very good. Yes, friends. Govindam, you please check your answer. Gurjit Saini, yes, you please check your answer. This is option C, sir. Yes, friends, all of you welcome to the session. The next question is displaying on the screen. Just now I told this one. Can anybody answer this one? Quick, quick. That's why once I am explaining any one question, not only on the answer, sir. What are the points I am giving? That points also you concentrate, students. We can answer different models of questions. Yes, friends, can anybody answer this one? Yes, sir. Digital measuring instruments use the following three types of A to D converters. Analog to digital converters, sir. Dual slope type, counter type, flash type. Counter type is also called ramp type, sir. You can take as a ramp type. The correct sequence for these converters in decreasing order of their speed, sir. Students, please see the statement here. Decreasing order of their speed, not increasing order. Then highest speed is which one, sir? Highest speed, decreasing order. If you take the speed, in terms of speeds I am comparing, highest speed is flash type, students. Highest speed is flash type. Flash type ADC is the highest speed. Next counter type, students. Next counter type. The next one is which one, students? Dual slope. The next one is dual slope. Least speed is dual slope, students. Least speed is dual slope. Then flash type is number 3. Next counter type 2. 3, 2, 1, students. In decreasing order, 3, 2, 1. Which one is correct, sir? Yes, Bhattacharya, it is not A. Answer is D, sir. Option D. Lowest speed is dual slope. The name itself it indicates that, sir. Dual slope integration. 2 times integration takes more time to get the output. That's why it is the lowest speed. Name itself it indicates dual slope. Like that you remember. Like that you remember, sir. Flash type, flash name. The name itself it indicates highest speed. Highest flash. The flash will we get very within less time. Microseconds, nanoseconds of time. That is the flash type ADC is the highest. Yeah, 3, 2, 1, sir. Please correct all of you. Yes, friends. Option D is correct, sir. Option D is correct. Yes, Govindan. Yes. A flash counter. So dual slope is the ADC. Flash type ADC. So it's a flash type ADC. Counter type ADC. Counter is different. Flash is different. Muhammad, you please concentrate on the answer. Please sir, correct that answer. Yes friends, all of you welcome to session. One more question is displaying on the screen. Can anybody answer this one? Quick. Very important model of question in ESE. Repeated model of question this. Can anybody answer these questions? Yes friends. Please concentrate these questions friends, all of you. Yes. Students. A 4.5 digital voltmeter is used for measurements. It would display the voltage value 0.3861 on a 10 volts range as it is measuring 0.3861 volts. Sir. In the measurement of 0.3861 volts, in 10 volt range, what it can display? How it can display? What is the display on 10 volts range? I think all of you know this one. All are operated DMM in our laboratory, sir. Digital voltmeter or DMM, the operation is same, sir. Okay. But digital multimeter we are using for not only for voltage, we are also measuring different parameters. We are measuring currents also. We are measuring resistance also. Now the question is, I think all of you know in DMM, there is range selector switch. 1 volt range, 10 volts range, 100 volts range, 1000 volts range. Like that there is a range selector switch is there. By changing that range selector switch, the display will change. Sir. Yes friends, first identify given voltage is which range display. Sir. Given is how much, sir? 0.3861 students. 0.3861 volts is, it is a 1 volt range display. It is a display in 1 volt range. It is a display in 1 volt range students. First identify given is which range display. Very good, Saujanya. Option B is correct. Sir. Very good. Option B is correct. Very good. For this question, option B is correct, sir. Very good. Very good. Yes, friends. First, identify given is which range display. It's a 1 volt range display. It's a 1 volt range display. Now we want which range display, sir? 10 volts range. If you put in 10 volts range, it's very simple, students. Remove one digit here, add one zero this side. 0.386, sir. 0.386. It is a 10 volts range display. If it is asked what is the 100 volts range display, sir? If you change the range selector switch to 100 volts range, then remove one digit here, then add one zero here, sir. 0.38. 0.38. Add one zero here. Next, if it is asked 1000 volts range display, if it is asked 1000 volts range display, sir, then what you can get, friends? Add one more zero here, 0.3. Then, but what it is asked 10 volts range? 10 volts range means this one, sir. 10 volts range is which one, student? This one, 0.386. That is 0.386. Which option is correct? Option B is correct. Very good, sir. In 10 volts range. But, sir, you are changing range selector switch, sir. Once we can shift into 10 volts range, it goes to 3.861, sir. The zero will be shifted like this. That is meaningless, sir. You are giving 0.3861. We are measuring 0.3861 volts, sir. How we can get 3.861 volt? That is meaningless. That don't think like this, sir. The decimal point is, but in this case the decimal point is not shifting. Removing one digit, sir. If the range changes, removing particular digit, one digit, then adding one digit at left side. Removing one digit at right side, adding one zero at the left side. Understand? Like this, we can extend the range. The display is like this. But finally, the display is how many digits, sir? 4.5 digit voltmeter means 4 plus 1. It is displays in 5 digits. It displays in 5 digits. 4 digit DVM will display only in 4 digits. But 4.5, it is extended. It extended by 1 digit, sir. That is 4.5 will display in 5 digits. 0.3861 means 5 digits. 0.3861. Yes, friends, please concentrate. Yes, good evening, Kumari. Kumari, welcome to the session. All of you, welcome to the session. Yes, friends. The next question is displaying on the screen. Yes, friend, this mega mark challenge, electrical engineering, June schedule, sir. Please go through these schedules, friends. Yes, friends, one more question is displaying on the screen. Can anybody answer these questions? Quick, friends. Yes, sir. All of you, welcome to the session. Very important models of questions that I am solving based on the digital voltmeters, friends. Who are preparing, mainly electrical and ECE students, who are preparing for ESE point of view and even for GATE point of view also. These questions, these models of questions are important, students. Most of all these questions are previous GATE and ESE questions. Yes, friends, please concentrate. Can anybody answer these questions, friends? Yes, friends. A 4-digit DVM with 100 millivolts lowest full scale range. With 100 millivolts lowest full scale range. Would have a sensitivity of how much? You want to find the sensitivity value. While resolution of this DVM is 0.0001. 0.0001. If the resolution is 0.0001, you find the what is the sensitivity, sir. You find the what is the sensitivity. Yes, friends, all of you, welcome to the session. Sir, how to write the sensitivity, sir? What is the solution for this problem, friends? The sensitivity equal to, yes, sir, resolution into lowest range, sir. You measure the resolution in a lowest range, that gives the sensitivity. Resolution into lowest range. Yeah, this is the formula for sensitivity, friends. Resolution into lowest range. Then what the sensitivity, friends? What the resolution is given, friends? A 0. The resolution is given 0.0001 into what the lowest range? It is 100 millivolts. 100 millivolts. Then how much we can get, friends? This we can get 0.01 millivolts. Okay, this is the sensitivity. Sensitivity equal to 0.01 millivolts. Very good, Savachina. That is also correct. 1 by 10 power 4 into range. Lowest range. That is also correct. That is 0.01 millivolts we can get, students. 0.01 millivolts we can get. Yes, friends, please concentrate. Sensitivity equal to resolution into lowest range. Resolution into lowest range. You also write this one. 1 by 10 power n into lowest range. Lowest range. Where n is number of digit. It's a 4 digit now. N equal to 4 you can substitute. Where n equal to digit. Number of digit. It is not number of bits. It is a number of digits. Number of bits is different. Number of digits is different. I think all are operated DMM in our laboratory, sir. DMM in our laboratory. Very good, sir. Sirivennala, option B is correct. Divi Govindan, very good. Option B is correct, students. Yeah. The next question is displaying on the screen. Can anybody answer this? Quick. Just now I given this formula. Yes, friend. What the resolution of a 4-digit digital voltmeter in 100 volts range? What is the resolution? If 4-digit digital voltmeter, resolution of a 4-digit digital voltmeter in 100 volts range is that. How to write resolution, sir? Resolution in a given range is written as resolution in a given range. Yes, friends. Very important formulas, friends. Resolution in a given range equal to, resolution in a given range equal to, yes, friends, 1 by 10 power n into range. 1 by 10 power n into range. It is a how many digit DVM? 4 digit DVM. 1 by 10 power 4 into range is how much, friends? 100 volts. Then how much we can get, friends? 10 millivolts. The resolution in a given range equal to 1 by 10 power n into range. That is 1 by 10 power 4 into 100. This we can get 10 millivolts. Which option is correct, friends? Option A. Sir, simple formulas, friends. 1 by, still now you don't know about this formula. Now onwards you remember, sir. Very important formula. The resolution in a given range equal to 1 by 10 power n into range, where n equal to number of digits. How many digit DVM? This is a 4 digit DVM. That's why I substituted n equal to 4. Then I am getting, in which range it is asked? 100 range it is asked. That's why I substituted 100. Yes, friends. This is option B. Very good. Siri Vanilla. Yes, not option B, sir. It's option B. I think that is the previous question you answered. Okay. Okay. Yes, friends. Please concentrate. The next question is displaying on the screen. Can anybody answer this quick, friends? Quick. The next question is displaying on the screen. Can anybody answer? Yes, friends. A 4.5 digit voltmeter is used for measurements. The resolution of voltmeter in 10 volts range is there. Yes, friends. One important observation here. Given is 4.5, sir. Given is 4.5 digital voltmeter. 4.5, where half digit, 3 by 4 digit, 5 by 6 digits, all these are to extend the range only. To extend the range. Point to remember, friends, is 4.5 is given, 4 3 by 4 is given, 4 5 by 6 is given. No need to consider these half digits, 3 by 4 digits and 5 by 6 digits. Because resolution is independent of, yes, friends, independent of, which one, friends? Independent of, yes, friends, half digit, 3 by 4 digit, 5 by 6 digit, etc. etc. It is independent. That's why even though 4.5 is given, you calculate only for 4 digit. Then what the resolution? Just now I given the formula. Whatever it is given, sir, that 4.5, 4 3 by 4, 4 5 by 6, like that it is given. No need to consider that digits. You consider whatever the full digits are there, that digits only consider. Then what is the resolution, sir? Yes, friends, resolution equal to 1 by 10 power n into range. Very important observation, this students. 1 by 10 power n into range. 1 by 10 power 4 into, it is what range, friends? 10 volts range. Then how much you can get, sir? 1 millivolts. Yes, friends. Option C is correct. Yes, Govindan. Very good. That is option C is correct. Very good. Very good. So option C is correct. Resolution equal to 1 by 10 power n into range. That equal to 1. Even though half digit, 3 by 4 digit, 5 by 6 digits are given, don't consider that one. Whatever the full digits are there, 4 digit, 3 digit like that, that digits only consider, sir. Don't consider that. Because resolution is independent of this. That I told already. Because of half digit, 3 by 4 digit, 5 by 6 digits, sir, only range is extended. Maximum value measure is extended. But resolution and sensitivity is not affected. That's the reason why resolution is independent of these digits. Resolution is independent of these digits. Very good, Sirivan. Very good, Saujan. That is correct. Yes, friends. The next question is displaying on the screen. What is the answer, sir? Okay, this is very important observation, sir. Given that what is the full scale values of 3 digit, 3.5 digit, 3 3 by 4 digit, 3 5 by 6 digit, 4 digit, 4.5 digit, 4 3 by 4 digit, 4 5 by 6 digits. Digital voltmeters in 1 volt range is dash. In 1 volt range it is asked, sir. Yes, students, all these are the digital voltmeters, sir. These are the digital voltmeters. Yes, friends. What is the in 1 volt range? In 1 volt range. It is asked in 1 volt range, friends. What is for 3 digit DVM? For 3 digit DVM, full scale value, sir. Full scale value in 1 volt range. Full scale in 1 volt range. Full scale in 1 volt range. Yes, now tell the friends. What the full scale in 1 volt range in 3 digit DVM? Just now I told it measures 0. Instead of 0 point, you take points, sir. Actually, display is in terms of point like this. 0.999. What about for 3.5 students? It is roll over by 1. 1.999. What is 3 3 by 4 students? What is the 3 by 4? Easy to write, sir. Easy to write. What easy to answer, students? 3 by 4. Roll over by 3, sir. Roll over by 3 means 3.999. This indicates, numerator indicate the rollover. Numerator indicate the rollover, students. What about 3 by 6, friends? 3 by 6. Numerator indicate the rollover. 5.999 over 5.999. It is in 1 volt range, sir. For example, here I asked only in 1 volt range. The same question is asked in 10 volts range. Full scale value in 10 volts range it is asked, sir. Just for understanding, I am telling students. 10 volts range. Then if it is asked for 10 volts range, then decimal point is shifted to right, sir. What is the maximum value, full scale value? 9.99, students. What is the full scale value? 19.99. In 10 volts range, it measures 19.99. Sir, why, sir, in 10 volts range, how it measures 19 volts, sir? Because it is multiplication by factor of 2. Okay, that is the meaning. Okay, this is 39. Just decimal point is shifted to right. 39.99. This is 59.99. It can measure. This is the meaning. Yes, friends, please concentrate. Just decimal point. If it is asked for 100 volts range, yes, 399, 199.9, 399.9, 599.9. Like that, the decimal point is shifted to right. Understand, sir? Okay. Then what about the 4 digit? Here, full scale value, full scale in 1 volt range. Full scale in 1 volt range, friends. Yes, friends, please concentrate. Full scale in 1 volt range. If it is a 4 digit DVM, can anybody tell? What is the, in 1 volt range, what is the minimum, what is the maximum value, sir? Full scale value. 0. That is 0.9999. Because it's the 4 digit. The display also in 4 digit. The display also 4 digit. What about in 4.5, students? What about in 4.5? Roll over by 1, sir. 1.9999 over. It is a full scale value, maximum value I am telling. What about 3 by 4, students? Roll over by 3. Numerator indicates the roll over, students. 3.999. What is the 5 by 6, friends? 5 by 6, sir. Then what indicate 5.9999 over. Okay, like this you can measure. Yes, friends. Okay. If it is asked for full scale, this is a full scale value in 100 volts range, friends. In 100 volts range. Can anybody answer this one? Please try by your own. Just decimal point is shifted to right. Decimal point is shifted. I am talking about the not 1 volt. I am giving the 10 volts range. If 10 volts range means only 1 decimal point. 100 means 2 decimal points. Yes, friends. Then what you can get, friends? This you try. This we can get 9.99. This is 19.999. Is it correct, sir? This is 39.999. Yes, friends. This is 59.999. Over. Like this we can. Similarly, you try for 100 volts range, 1000 volts range also. How it is displayed. How it is displayed. Yes. I think you got some clear idea how the display is there for different ranges. It's a full scale values. It is a full scale values. Is it okay, sir? Is it okay? Yes, 39.999, 59.999. Like this it can display. Clear, friends? This is a question number 10. Quick, sir. This is the question number 11. Very important model. This model is important. All the competitive exams, GATE, ESE, in all the competitive exams, this model is repeated. But it's somewhat calculation, but not lengthy problems. Just 1 or 2 steps only. Maximum answer is there in question itself. In question itself, answer is there, sir. But here calculating the minimum count is important. Here calculating the minimum count is important. Yes, friends, please calculate. You want to find what it is given, sir. Error specification is given. How much error is given, friends? Error equal to, generally in the case of digital voltmeters, error is specified as plus or minus 0.2% of reading. In question itself, answer is there, friends. 0.2% reading plus 10 counts. 10 counts. Okay, this is the error. First you calculate, here you want to calculate the maximum error. Once you can calculate the error, percentage error you can easily calculate. Error equal to, already in the question itself it is given, sir. Substituting the minimum count is important here. Plus or minus 0.2%, 0.2 by 100 into how much reading we are measuring, students? 100 volts we are measuring. How much we are measuring? 100 volts plus 10 into, here count means minimum count you substitute. Minimum count you substitute. Substituting the minimum count is important. Once you know the concept of substituting the minimum count, then this type of problems are very easy. Then error equal to, yes students, plus or minus this 0.2 plus 10 into minimum count. 10 count means here minimum count. Now tell the students, given is which voltmeter? 4.5 digital voltmeter or DMM. DMM or digital voltmeter. The error or accuracy specification is same, students. Error or accuracy specification is same. Yes friends. How to substitute the minimum count? What is the minimum count? How to substitute, students? Given is 4.5 digital voltmeter. We are measuring how much voltage, students? 100 volts. Using 4.5 digital voltmeter or digital multimeter, 100 volts is measured in which range, sir? In 1 volt range, maximum we can measure 1.999. In 10 volts range, maximum we can measure 19.999. But in 100 volts range, 199.99. 199.99 means then 100 will come. That means using 4.5 DMM, yes friends, 4.5 DMM, 100 volts is measured. 100 volts is measured. Yes friends, it's a 4.5 students in 100 range. In which range we can measure, friends? In 100 range. We can measure in 100 range. 4.5 DMM is measured in 100 range. Now you want to find the minimum count in 100 range. Minimum count in 100 range, friends. Now tell the friends, using 4.5 DMM, what is the minimum count in one range? In 1 volt range, what is the minimum count, friends? First you identify what is the minimum count in 1 volt range. Please concentrate, friends. In 1 volt range, what is the minimum count? Using 4.5 DMM, minimum count is 0.0001. 4.5 means 4 plus 1, 5 digits are there. 4.5 means 4 plus 1, 5 digits, friends. Because of half digit, 1 digit is added. 4.5 means don't add 1, but extra 1 digit. Because of half digit, 1 is added. 4 3 by 4 means 4 plus 3, like that, don't add. Because of 3 by 4 digit, 1 extra digit is added. That is also 5 digits. Don't add 4 plus 3 like that. 4.5 means because of half digit, 3 by 4 digit, 5 by 6 digit, 1 extra digit is added. 4 digits will displayed as a 5 digits. 0.0001, sir. But in which range we are measuring 100 volts? In 10 volts range, first we calculate. What is the in 10 volts range minimum count? 0.001, sir. It shifted to left. Yes, friends. Next. Decimal point is shifting to right, friends. 0 is left. Then in 100 range, in 100 volts range, because we are measuring in which voltage range? 100 volts range. The 0.001 we are measuring. Yeah, this is the minimum count. It is the minimum count in 100 range. It is the minimum count in 100 range. Minimum count in 100 range. Now that you want to substitute. Then what the error equal to, students? What the error equal to? Plus or minus 0.2% of reading. 0.2 by 100 into 100 plus 10 counts. 10 into minimum count is how much, friends? 0.01. Is okay, friends. Then how much we can get? Plus or minus 0.2 plus this is how much? 0.1. How much we are getting, students? Plus or minus 0.3. Yeah, this is the error. But given is percentage error. How to find the percentage error, friends? How to find error by true value into 100. Error by true value into 100. Error is how much, friends? Plus or minus 0.3. True value is how much, friends? How much we are measuring? 100 volts into 100. How much we can get, friends? Plus or minus 0.3%. This model is very important. This model is very, very important. Very good, Saujanya. Yes, minimum count is 0.0. Very good, very good. Rushita, very good evening. Rushita, very good evening. Welcome to the session. Yes, friends. Yes, sir. This is answer is which one, sir? Yes, plus or minus 0.3%. Very, very important model. It's a 5-star model, students. Plus or minus 0.3% is the right answer. Here, answer itself there, sir. In question itself, answer is there. But Substituting the minimum count is important. First identify given voltage is measured in which range using given DVM. By using given DVM, given voltage is measured in which range. First you identify that one. From that you calculate the minimum count. You substitute that minimum count. Then you can get the answer. Yes friends. Very good sir. Option C is correct. Next question. One more question is displaying on the screen. Can anybody answer? Who are the very good knowledge in digital subject? You can easily answer these questions. Who are the good knowledge in the digital subject? This question can easily answer. Yes, quick friends. I think most of the EC students, electrical students, if you have the good knowledge on digital, you please answer this question, sir. Fraction of minute you can answer. This is the question based on the dual slope ADC, sir. This is the question based on the dual slope ADC. Yes, friends. In a dual slope ADC, the reference voltage is 100 millivolts. And the first integration period is 50 milliseconds. The input resistor of the integrator is 100 kilo ohm. And the integrating capacitor is 0.047 microfarad. For input voltage of 120 millivolts, the second integration period will be dash. Yes, friends. This is the question. Very good. Very good, sir. 60 milliseconds is right answer. Very good subject. Yes, sir. It is a 60 milliseconds is correct answer. Yes, friends, please concentrate. What is the solution for this one? In dual slope ADC, sir. All of you well know this one. In a dual slope ADC. In a dual slope ADC. Yes, friends. What is the formula? Vm by V reference equal to T2 by T1. T2 by T1. Vm is the input voltage, sir. Vm is the input voltage. Yes, friends. Vm is the input. This is T1 is the first integration period. T2 is the second integration period. Then what is the T2 equals, friends? Vm by V reference into T1. How much Vm it is given, friends? How much Vm it is given? Yes, friends, please concentrate. 120 by how much V reference? 100. This is T1 is 5 milliseconds. Sorry, it is how much it is given, friends? It's a 50 milliseconds. Then we are getting 60 milliseconds we can. Then what is the second integration period, sir? We are getting 60 milliseconds. Very good, sir. It's a 60 milliseconds. Yes, friends, please concentrate. This is the formula for dual slope, sir. I think you know RAM type ADC is also there. In RAM type ADC, students, that formula is different. This is for RAM type ADC. What are the formula, students? For RAM type ADC, this formula you know. Please, these two formulas are very important. I am not solving this RAM type ADC. You know in digital subject. Then Vm by V reference equal to what the formula, students? This is directly proportional, sir. Tm by T reference. Tm by T reference. But here inversely proportional. Vm T2, V reference T1. Vm by V reference equal Tm by T reference. Tm is the time at which the input voltage is connected. T reference is the time taken for fall of reference voltage. In RAM type ADC, which waveform is taken as a reference waveform, sir? It's a ramp signal. That is the time taken fall of the ramp signal. Is nothing but a T reference. That's a Vm by V reference equal Tm by T reference. Sir, but in this problem, resistance is given, capacitance is given. Why you are not considering? That is one of the advantages of dual slope ADC. The dual slope ADC output independent of the resistance and capacitance values. It is independent of the resistance and capacitance values in the circuit. Yes, friends. Is it okay, friends? How much we are getting? 60 milliseconds we are getting. Okay. The next question is displaying on the screen. Can anybody answer? Quick, friends, quick. A digital multimeter is used for the measurement of the following. What are digital multimeters are? DMMs, friends. Digital multimeter, DMM. All are operated in our laboratory, in colleges, sir. All are operated. A digital multimeter is used for measurement of the following. Select the correct answer using the codes given below. Yes, friends. Which one you can measure using DMM? Which one you can measure using DMM, friends? Quick, friends. Which parameters we can measure using DMM? Yeah, both AC and DC voltages we can measure. Both AC and DC currents also we can measure. We can also measure resistance. Using DMM, we can also measure resistance. But we can't measure the frequency. We can't measure the power. Then 1, 2, 3 is correct, sir. Option D. Is not option B. Is not option B. Govindan, we can't measure the power by using DMM. Power we cannot measure. I think all are operate DMM in laboratory, sir. We are measuring AC and DC voltages, AC and DC currents, resistance. And we are not measuring frequency. We are measuring the power. Oh, sorry, we are not measuring the power also. Mainly these three parameters we are measuring. Yes, Sirivanala, it's very good. Option D is correct, sir. Option D is correct. Yes, friends, please concentrate quick. At this model, you please solve as an assignment. This model I already solved, sir. Just calculating the minimum count. The answer for this one is, I am giving this 50 plus or minus 0.75 ohms, sir. Please check your knowledge by solving this question. Please check your knowledge by solving this question. Yes, friends. So please solve this question. This model I already solved with respect to voltages. Multimeter can also measure resistance. Yes, friends. 50 plus or minus 0.75 ohms, sir. So please try to solve that one. Yes, friends. Please concentrate. Can anybody answer this question, sir? Can anybody answer this question? Quick. Yes, friends. Yes. Assertion. The resolution of 3.5 digit voltmeter is 0.0001. 3.5 digital voltmeter. Is it correct, sir? 0001. The resolution of 3.5 digital voltmeter. 0.0001. Is it correct, friends? Resolution equal to 1 by 10 power n. Resolution equal to 1 by 10 power n, sir. 1 by 10 cube. 1 by 10 cube means how much, friends? This we can get 0.001. 0.001 you can get. The resolution is 0.001. But it is given 0.0001. Is it correct, friends? This is the wrong. Next. Addition of half digit to a digital voltmeter increases the range of the meter. Addition of half digit to a digital voltmeter increases the range of the meter. Yes. Reason is correct. Assertion is wrong. Reason is correct. Which option is correct? Option D is correct. Very good, Sirivendra. Very good. Yes, sir. Very good, sir. Yes, friends, please concentrate. Assertion is wrong. Reason is correct. And last question, friends, please concentrate. This is the last question. These are the different models of questions in the digital voltmeter, sir. With this series is completed, sir. I started with the CRO, ending with the digital voltmeter. The electronic measurement series is completing with this question. In the next coming sessions, I will start the new series. Maybe I will start with either power systems or missions or power electronics. I will start, sir. You please ready for that series also in our YouTube session. Yes, friends, in Gradeup YouTube, the next series I will start either missions or power systems or power electronics. In these three subjects, I will start one series, friends. Question series only. Friends, in a dual slope type digital voltmeter, an unknown voltage is integrated over 100 cycles of the clock. If the signal has a 50 Hz pickup, this signal has a 50 Hz pickup means 50 Hz noise effect. 50 Hz noise effect. The maximum clock frequency can be. Then to eliminate this 50 Hz frequency noise effect, what the maximum clock frequency you want to maintain? I told already, in a dual slope digital voltmeter, the noise effect is eliminated. How the noise effect is eliminated? Very important, friends. In dual slope ADC, in dual slope DVM, yes, friends, please remember this point. To eliminate noise effect or to reduce noise effect or to eliminate noise effect. It eliminates the noise, sir. To eliminate noise effect. This is the conditions, friends. To eliminate noise effect. Noise effect. Generally, that 50 Hz sinusoidal signal will superimpose on the input signal. Just like this is our input signal. That noise signal is superimposing on the input signal. Then how this noise effect is eliminated? To eliminate this noise effect, sir, the first integration period is always selected as a integral multiples of. This first integration period is always selected as a integral multiples of time period of the sinusoidal wave, where Ts is the time period of the sinusoidal waves. Ts is the time period of the sinusoidal wave. Why you are selecting like this, sir? To eliminate which one, students? Noise effect, 50 Hz frequency noise effect. To eliminate this one, we are selecting T1 equal to N into Ts. This is the selection to eliminate the noise effect. But what it is given? The first integration period is given as 100 cycles of the clock. It is given as a 100 cycles. 100 into T clock, students. 100 into T clock. This T1 is given N by Fs, students. N by Fs. Ts I written as Fs. This 100 by F clock. T clock I written as a 100 by F clock, students. Okay, this concept you already know even in digital hours. N by Fs. Now I want clock frequency, students. You want to find maximum clock frequency. The maximum clock frequency equal to 100 into Fs by 100 by F. 100 into Fs by S, friends, into N. For FCLK maximum. For FCLK maximum, when you can get maximum, sir, N should be minimum. N minimum. Yes, friends. For FCLK maximum, N should be minimum, friends. What is the minimum value of N? N minima equal to 1 you can select. Then what the maximum clock frequency, sir? What the maximum clock frequency? 100 into, this Fs is the sinusoidal signal frequency, sir. It is the sinusoidal signal frequency. What the sinusoidal noise frequency, friends? It is given as a 50 by 1. Then how much we can get, friends? We are getting 5 kHz. Then maximum clock frequency equal to how much, friends? We are getting the 5 kHz. The maximum clock frequency 5 kHz. Yes, within Hemant, I will tell within 2 or 3 days it will come. Yes, friends. The maximum clock frequency equal to, it's not 50 kHz, sir. It is a 5 kHz. You please correct this one. It's a 5 kHz. It's given 100 cycles only. 100 cycles. To get the maximum frequency, N must be equal to 1. Sir, why you select this N1, T1 equal to N into Ts? To reduce the, to eliminate the, which one, students? Noise effect on the input signal. To eliminate the noise effect on the input signal. Yes, friends. Yeah, this is about what exactly different types of models of questions based on the digital voltmeters. With this, the series of electronic measurement questions for ESE is completed, friends. Please go through all these lectures. We can get more important models of questions. These models are very important who are preparing for ESE and is also important for gate point. Please go through all these series, friends. Who are not attended for this series, please go through all these videos, friends. Yes, friends, this is electrical engineering live quiz every Tuesday, Thursday and Saturday in our Gradeup. Please participate. Earn while you learn, sir. This is the program Earn while you learn. Yes, friends. Students, this is Gradeup Super. Subscribe for Gradeup Super. Get the so many benefits, sir. Get the so many benefits. Yes, thank you, Hemant. Yes, friends, for more information, contact this number, students. Yes, friends, this is Gradeup Super. Thank you, students. Thank you very much. Please go through the whatever the electronic measurement question series I given, starting from CRO ending up to digital voltmeter. That is more useful, students. Next coming sessions, I will start maximum power electronics or power system or missions. Any one series I will bring, sir. Question series. That is more useful, mainly for electrical students. Yes, friends, thank you. I am ending the session.